Professor Meow asks, Bitcoin full node versus Ethereum archival node. Does Ethereum need a sufficient amount of users to run an archival node? Recent crypto Twitter drama revealed that a few entities are running a full archival node. Vitalik and other proponents claim that you can create the archival version using a full node. Is that true? When would you use an archival node versus a full node in Ethereum? In Bitcoin, would the full node be the equivalent of Ethereum's archival node? Why do Bitcoiners emphasize that a sufficient user number must run full nodes when Ethereum does not? Does it have something to do with different use cases? A lot of questions packed together, but all around the same theme. First of all, let's clarify terms. The term full node has changed meaning over the past 6-7 years and means a different thing. It means a different thing within Bitcoin, and also means a different thing between Bitcoin and Ethereum. Originally, a full node was a node that was not only doing full validation, but also keeping a full copy of the entire blockchain. Now, back in, I think, 2015, we had the first implementations of pruning. And pruning allows a node to maintain the most recent state of the blockchain and do full validation without keeping a historic record of, for example, spent UTXO and all of the transactions that have ever happened. So you can set your Bitcoin node to prune. And what does that mean? Is it no longer a full node? It just changes the meaning of the word full node. It's creating additional distinctions. So previously we had a fully validating node, which effectively was also an archival node because it kept the whole copy of the entire blockchain, or you had a lightweight node, which didn't do full validation and didn't have a full copy of the blockchain. Then the full nodes split into two. Essentially, you had full nodes that could do all the validation and are doing authoritative validation of transactions and blocks on their own and keeping the current state. So that's the kind of node that you could run at home, for example, to validate your own transactions and make sure that you've been paid. But you don't have to keep a whole copy of the blockchain anymore because transactions that have already been spent, outputs that have already been spent, are not relevant, and you can prune those and keep only a subset of the state. And that's done with the pruning command. On Bitcoin Core, you can tell your system to, say, prune your blockchain down to 50 gig. And it will keep, historical information for the last several weeks, but before that, it will only keep the aggregated state rather than all of the historical information. If you tell it not to prune and you keep a full copy of the blockchain, that's an archival node now. So we've changed the words for it. And archival nodes exist in Bitcoin, of course. I run unpruned or archival nodes. And that means I'm using up 250 gigs of disk space in order to have a fully indexed copy of the entire Bitcoin blockchain from Genesis block until today. Ethereum works differently. It works differently in that it has a much more complicated state tree, which takes up a lot more space. But it also has a lot of intermediate state that can be discarded without changing the validity constraints or validation constraints of a node. So running an archival node in Ethereum means keeping the execution state and receipts of every transaction for every contract that's ever been executed on Ethereum. And that takes a lot of space. Last I looked, I think it was over 2 terabytes of disk space to do that. And also, it's very difficult to sync because in 2016 and 2017, there were a couple of denial of service attacks. And these denial of service attacks took advantage of vulnerabilities in the accounting for gas for certain types of operations that were either memory heavy and CPU intensive or disk intensive, or used up a lot of space on the blockchain. So there were 2 periods during which Ethereum was bombarded by either transactions that took a very long time to validate or transactions that created millions of empty accounts that had to be stored on the blockchain for no reason whatsoever, bloating the blockchain. There were 2 hard forks to erase this information and remove all of these wasted transactions, essentially stop the denial of service and change the accounting so it can't happen again. But if you start booting a node from zero and you try to validate the Ethereum blockchain from scratch, when it reaches those periods in time in 2016 and 2017, your node will get bogged down. You're going to need a lot of CPU and a lot of disk space and a lot of memory just to be able to unpack, validate, and go over those transactions. So most nodes don't do that. They simply fast forward to a checkpoint after that point and ignore the detailed validation of all of those transactions. It's been done once. It doesn't need to be done again by your node in order to have a full copy. And that's one. The other one is that Ethereum is much more aggressive at pruning because its scalability constraints or its scalability characteristics are much worse than other blockchains because it has to keep all of the state of the contracts. So Ethereum uses more aggressive pruning, which means that very, very few, if any, nodes keep a full archival copy of the entire Ethereum blockchain since the Genesis block. That doesn't mean they can't validate. That doesn't mean they can't even validate all of the information correctly based on the latest state. It just means that if you ask them to go and look at a specific execution of a contract in the past that's already been validated and reconstruct that, they need to rebuild the blockchain again. And it's very difficult because you're not going to find any peers who are going to give you that data because there aren't that many and they're not online all the time and they don't have the bandwidth to bootstrap other nodes so easily. So it's difficult to do that in Ethereum. Different use cases, different scalability characteristics, different culture between Ethereum and Bitcoin, and as a result, you get these differences between archival nodes.